Hello and welcome to a video that reviews different classifications of triangles. Now these are classifying by angle and classifying by sides. When you have three acute angles, we call that an acute triangle. Pretty simple. And I'm just going to use the picture of a triangle when I mean the word triangle every time instead of writing it out each time. One obtuse angle, we call that an obtuse triangle. One right angle is a right triangle. And when all three angles are the same, we call that equi, E-Q-U-I, angular. Equiangular. Now, equiangular is a subset of acute triangles, but it's more information. So if you do happen to run across an equiangular triangle and you're asked to classify by angles, it's better to call it equiangular than just to call it acute, because that's giving more information. Okay, so let's just look at a couple of examples of a triangle. This is a figure with a bunch of triangles in it, and we're just going to look at each triangle and see if we can identify what kind of triangle we're looking at. So triangle CDE, let's actually find that and highlight it so we make sure we're looking at the right triangle. So CDE is this triangle right here. And right there in that corner of that triangle is a right angle, which makes it a right triangle. Okay, so this one is a right triangle. Now, in case you're wondering what's circled here, I'm just going to do a sampling of the problems on this paper. Not all of them, just the ones that are circled. All right, triangle BCE. So let's start over. Let's look for triangle BCE. So this one starts at B, CE goes this way, BCE. And there's the triangle that we're looking at. All right. Now, this triangle, this is an obtuse angle up here, so that makes it an obtuse triangle. All right. And by the way, just a little bit of argument towards that is that if we look at this triangle right now, we know a triangle has 180 degrees, and we know that this is 90. So each one of these has to be less than 90. So if this angle up here is less than 90, then its linear pair to add up to 180 must be more than 90. So that's just one way of sort of making an argument to try to make your case if you're trying to decide whether something is obtuse and you don't have any markings to prove it. All right, so triangle ABE. Let's look at ABE. So we have ABE. Now that one exactly fits the look of an equiangular triangle. So that's what we're looking at. Equiangular. Okay. Let's move on. Let's look at classifying triangles by sides. Now, if three sides are all the same, we call that equilateral. Starts the same as equiangular, EQUI, except lateral is just another word for side. So equilateral means equal sides. When we have two sides that are the same, we call that, this is an equilateral triangle. We call this an isosceles triangle. And when nothing is marked the same, we can go ahead and assume that they're all different, unless there's some reason to logically conclude that the two of them are the same. And so that would be a case like this last one, no congruent sides. That would be a scalene triangle. All right, so let's just look at one example of these three. Let's look at number 8, at the triangle JKN. So let's find it. JKN, that's the one that has all three sides the same. So that's an equilateral triangle. Equilateral. Okay, easy enough. All right, let's look at a couple of these. Now we're going to classify these three triangles by both their angle and their side. So just because we learned it this way, we just saw it this way, we're going to put the angle first. This is a right triangle because it has a right angle. So this is a right. Now the sides second, and we see two congruent sides. Those tick marks means they're congruent. That's a right isosceles triangle. All right. Number 10, we've got an angle that is 114. That makes it more than 90. That's an obtuse. So as far as the angle part, it's obtuse. And as far as the sides, again, we're going to use that assumption that if we're not told that it's the same, we have no reason to think it's different. We're going to say it's different. So this is going to be obtuse scalene. All right, and this last one is also obtuse because we're given a 97-degree angle, so that makes it obtuse. But we're also told the two sides are both 5. That means they're the same, so it's isosceles. And there you go. Okay, let's look at some examples that have a little bit more to them. So here we're going to look at 2 examples where we're going to try to determine, we're going to classify by both angles and sides, but this is in a much bigger diagram. So let's find the triangle UQR. So UQR, U is over here, Q and R. So it's this triangle here. All right, well that triangle is obtuse because it has a 120-degree angle and it's isosceles. So that's obtuse, isosceles. I think I'm going to go back to using just a picture. It takes too long to write the whole word. All right, now let's look at number 20. So 20 is triangle PQT. PQT is this triangle over here. Let's see if we can get that highlighted. All right, now this triangle is interesting because this angle up here is part of these 2 intersecting lines. If they form a right angle up there, all 4 angles are right angles. So this is definitely a right triangle. So that's the first part. That's the angle part. And we know that one of the sides is 8, the other 16, and the other doesn't say what it is, so we're just going to assume it's different. So this is a right scalene. Whoops, it goes down here. All right. So when you look at these others, make sure that you are paying attention to all this information here. So remember that if PR bisects angle SRT, we have to find that. So here's PR, and here's angle SRT. That means that these 2 angles have to be equal to each other. All right, and if U is the midpoint of RT, U is right in the middle of RT, that means that these 2 segments have to be equal to each other. They have to both be 8. That's another way of doing it. Okay? All right, so let's leave that one. Now the next type of problem here involves using the distance formula. So if we have coordinate pairs and we want to find the distance, we've got to use that good old D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Distance formula. All right, we can use a shortcut of that distance formula. We can also say that's equal to, I like to just say the difference in the x's and the difference in the y's. So the difference in the x's squared plus the difference in the y's squared. Well, I'll show you both ways of doing it. We're just going to do 3. We have to find 3 lengths to decide what kind of triangle we have. So these are 3 vertices of a triangle. We don't have to graph it. We just have to find the length of all 3 sides. So we have to find the length of JK. We have to find the length of KL. And the only other combination of sides would be JL. So we'll find the length of JL. Now, if all of these lengths are the same, we're going to call that equilateral. If they're all different, we're going to call it scalene. And if 2 of them are the same, the other one's different, we're going to call that one isosceles. All right, so let's look at my method here, the difference in the x's, difference in the y's first. So let's say for JK, and we're focusing just on these right here, I want to look at the difference in the x's from -7 to -9, and that's a 2. That's a difference of 2. So I have 2 squared. Then I want to do the same thing with the difference in the y's. So I have how far is -7 from 1? That's a difference of 8. So plus 8 squared. Saves me a little bit of the tedious work of distance formula. This is the square root of 4 plus 64, or the square root of 68. Let's do the second one using the distance formula. So in order to use the distance formula, we're going to choose K and L. So this is K and L. We're going to we have to choose what's x1, y1, and x2, y2, and then plug those into the formula. So the first part of the formula is the square root of x2 minus x1. So that's -1 minus -9. So that's -1 minus -9 squared. And then y2 minus y1, that's -1 minus 1. -1 minus 1 squared. Okay, let's see where that gets us. -1 minus -9, well, subtracting a negative is the same thing as adding, right? So this is -1 plus 9, which is 8. So this is 8 squared. And this one, -2 minus 2, that's -2 squared. Now it didn't matter that that's negative, because when we square it, we're still going to get a positive number here. So this is going to be 64 plus 4. Still 64 plus 4, still the square root of 68. It's the same as the first one was, a little bit longer using the distance formula. So for the last one, I'm going to go back to my method, which now we're focused on J and L. So I'm focused on J and L. So the difference in the x's, -7 to -1, those are 6 units apart. So that's going to be 6 squared. And the distance, or the difference from -1 to -1, -7 to -1 for the y's is -6. So that's also 6. So that's plus another 6 squared. So this would be 36 plus 36. That's the square root of 72, and that's different from 68. So two of them are the same and one of them is different. So this would be an isosceles triangle. Now we're only classifying these by sides. We don't have to classify them by angles. Okay, we got one more example. In our last example, we're given an isosceles triangle. We're told that it's an isosceles triangle, and we're also told that DE and EF are congruent. So looking at the triangle, I can mark DE congruent to EF. The ones that look like congruent are the ones that are congruent. Well, that allows me to write an equation to find x. Now I'm looking for the x and measure of each side, no angles. So since they're congruent, I'm going to set them equal. 8x minus 13 equals 5x plus 17. And then we'll just subtract 5x from both sides. May as well add 13 to both sides. And we end up with, on the left side, 3x. On the right side, 30. Dividing by 3. I just gave away the answer, didn't I? Dividing by 3 tells us that x equals 10. So we're on our way. We found x. So if we want the length of the sides, we just plug x in. So this one will be 8 times 10 minus 13. This one will be 5 times 10 plus 17. And this one in the bottom will be 10 plus 21. Okay, so 80 minus 13, 80 minus 10 is 70, so this would be 67. 50 plus 17 is also 67, and we have that way of checking. We expect them to be the same, and they are. And then 10 plus 21 is 31. So we can just write this out now as our final answer. So we can say DE is 67. EF is 67, and DF is 31. And that's it. Okay, hope you found this video helpful.